Now, when it comes to a topic like solubility product, we have a basic idea about solubility, saturation, unsaturation much before class 11. Naturally, we'll need to revisit those ideas when I present a very simple case to you. First of all, if you have seen solubility products from any of the textbooks, you will find this in ionic equilibrium. A representation like KSP, like Ka, Kb, Kc, Kp, would be a constant when it comes to solubility of certain salts, and this term KSP will be called the solubility product. Let me right away start with a very, very common, simple experiment or situation. But suppose I give you a solution having a precipitate of AgCl. So you have a precipitate of AgCl here. You know AgCl is a curdy white precipitate. Again, before I go into other aspects of this topic, let's be clear on one part. Like KKB is for weak acid weak bases, the concept of KSP will be for sparingly soluble salts. This will be for sparingly soluble salts. So sparingly soluble salts are the ones which are very less soluble and are generally taken as precipitate. So chances are you would have known AgCl as a curdy white precipitate, AgBr as a yellow precipitate, barium sulfate as a white precipitate, insoluble in mineral acid and all. So I repeat, like KKBr for weak acid weak bases, the concept of KSP will be for sparingly soluble salts, which are generally taken as precipitates. So it will not be taken for a sodium chloride or a silver nitrate, where you will come to know in future that all sodium, potassium, ammonium salts are soluble. All nitrates, bicarbonates, acetates are generally soluble. But AgCl, you know, is a curdy white precipitate. And please respond with a yes or no. The physical presence of a precipitate is a confirmation of this solution being saturated. Yes or no? ये सैचुरेटेड है तभी तो प्रेसिपिटेट है. अगर सैचुरेटेड नहीं होता तो ये डिसॉल्व कर जाता. So I repeat, the physical presence of a precipitate is itself a proof of the solution above it being saturated. अगर ये saturated नहीं होता तो डिसॉल्व हो जाता. अब AgCl का precipitate है, AgCl का saturated solution है. इसमें और AgCl डालोगे तो AgCl precipitate करेगा, dissolve नहीं करेगा. That is the basic concept of saturation. Let me tell you what you're going to experience now. You don't need to add AgCl. You add silver nitrate. You'll get to know that all nitrates were soluble. So silver nitrate is very, very soluble. Or you add sodium chloride, potassium chloride, ammonium chloride. I told you, you'll get to know all sodium, potassium, ammonium salts are very, very soluble. सोडियम क्लोराइड डालो, AgCl का प्रेसिपिटेट होगा. सिल्वर नाइट्रेट डालो, AgCl का प्रेसिपिटेट होगा. मतलब क्या है? इसमें तुम कोई भी सोर्स से Ag प्लस डालो या कोई भी सोर्स से Cl माइनस डालो, प्रेसिपिटेट AgCl का हो. You add Ag plus from any silver salt, which could be very soluble, or you add Cl minus from any chloride, which would be very soluble, and you'll see a precipitate of AgCl. And doesn't it tell you that the saturation is not in terms of AgCl? The saturation is in terms of Ag plus and Cl minus? Yes or no? कोई भी सिल्वर सॉल्ट से अगर AgCl का प्रेसिपिटेट हो रहा है, कोई भी क्लोराइड से अगर AgCl का प्रेसिपिटेट हो रहा है, इसका मतलब ये जो सैचुरेशन है ये सॉल्ट का नहीं है. इट्स सैचुरेटेड इन टर्म्स ऑफ Ag plus and Cl minus. Yes or no? पहला बात. दूसरा बात, जो तुमको यहां पर एक प्रेसिपिटेट दिखता है ना, सिटिंग आइडल एट द बॉटम ऑफ द सॉल्यूशन, ट्रस्ट मी, this keeps on dissolving and precipitating at the same rate. this keeps on dissolving and precipitating at the same rate. ये अगर क्लोरीन 35 है और यहाँ पर मैं क्लोरीन 37 दूंगा, थोड़ा देर में क्लोरीन 37 सोल्यूशन में आ जाएगा. यू आर गेटिंग मी? ये तो प्रेसिपिटेट होना चाहिए. इट्स गो ओनली टू द प्रेसिपिटेट. But at some point of time, you'll find this Cl minus, which is obviously falling down in the solution as well. So that is why one ionic and two equilibrium. This topic is in ionic equilibrium. So a few ideas will get revisited. It's not like everything which is taught before class 11 is not true, but you will want a better understanding. As I told you, यहाँ पर AgCl का सैचुरेटेड सोल्यूशन है, ऑलराइट, और AgCl डालोगे तो AgCl प्रेसिपिटेट होगा. पर कोई भी सिल्वर सॉल्ट डालने से अगर AgCl प्रेसिपिटेट होता है, कोई भी क्लोराइड डालने से अगर AgCl प्रेसिपिटेट होता है, इसका मतलब है द रियल सैचुरेशन इज इन टर्म्स ऑफ Ag plus and Cl minus. It's not in terms of AgCl. Yes or no? And the concentration of Ag plus and Cl minus, which is represented in square brackets as molarity, at this temperature would be a constant, and this will be called Ksp. So at a given temperature, see, by default, the medium, universal medium, solvent, universal solvent will be water. So all the discussion would be keeping an aqueous solution in mind. And as I did tell you, the concept of saturation needs to be revisited. Yes, solubility is going to be a constant. Yes, solubility is going to be a constant, but that would be rather a function of Kp. And what's actually saturation is for this aqueous solution at this temperature is in terms of this ionic product. You're getting me? Which is Kp. Now, if this ionic product, and I can call it ionic product because it's the concentration of the ions and the product of the concentration of ions, so let me call it ionic product. So when the ionic product is equal to Ksp, you claim this solution is saturated. This is a constant like KCKP. This is a constant like KCKP. And every time the ionic product in a given solution at a given temperature is equal to the Ksp, you will call it saturated. This gives me another definition of Ksp as well. You can very well define Ksp as the ionic product of that particular compound or salt at saturation. A solution having this IP less than Ksp would be called unsaturated, and a solution having IP more than Ksp would be called supersaturated, or basically the situation of precipitate. So every time you want to precipitate something, you'll have to exceed the value of Ksp, and only if the ionic product is over or more than the value of Ksp, you'll have a precipitate of this. बच्चों लोग हाँ ना बोलो. So this is the basic fundamental approach to solubility which I wanted you people to have. As I did tell you, maybe before class 11, solubility was all grams per 100 ml. It was a constant. There is nothing wrong in that. But yet again, the story is as simple as it looks. AgCl का precipitate दिख रहा है, ये AgCl में saturated है. AgCl डालोगे तो AgCl precipitate करेगा. पर सिर्फ Ag प्लस डालने से भी AgCl प्रेसिपिटेट करता है, सिर्फ Cl माइनस डालने से भी AgCl प्रेसिपिटेट करता है. मतलब the real precipitation is in terms of the real saturation is in terms of ions. What's eventually constant is the product of the concentration of the ions. To precipitate AgCl, you need not add AgCl. You add any source of Ag plus or you add Cl minus from any source. So basic saturation or that constant term in equilibrium in aqueous solution at saturation is Kp, which is the end product. Okay? You all happy with this? So we'll keep it simple. You know, the textbooks they make it very messy. The textbooks will have an approach which would look very, you know, confusing at times. It's as simple as it looks. Hope I can remove this filter. I can rub it off. And you understand two things. The constant is the product of the concentration of ions at saturation, which is Kp. Naturally, in a solution where this product is less than this constant value, you can add more Ag plus, more Cl minus to it. So that will be deemed unsaturated. And to precipitate something, you'll want to cross the Kp value, means you'll want to ensure that Ag plus Cl minus is exceeding Kp. Relation between KSP and solubility. If it's a binary salt means a salt which produces two ions, like AgCl, Ag plus Cl minus, like AgCl, Ag plus Cl minus. If it's a binary salt of the type Ba, if it's a binary salt of the type Ba, now naturally there will be an equilibrium between the solid form precipitate and the ions which it's producing. And if the solubility is, you understand that there's an equilibrium between the ions which are there in the solution and the form which is in the precipitate form. So I'll avoid writing solid every time because the small s will be taken as solubility more often than not. The only difference will be maybe before class 11, you were taught solubility in terms of grams per 100 ml. Now solubility will be in moles per liter. Everything will be in molarity. Everything will be in molarity. Now suppose the solubility of the salt Ba is S moles per liter. So this is supposed to give you S moles of B plus and S moles of A minus. Fair enough? Okay. And KC, which is supposed to be the ionic product of the saturated solution. See, if the solubility is S in pure water, the maximum amount of B plus and A minus, which will be there in a saturated solution, will be S moles per liter of B plus and S moles per liter of A minus. And if this is equal to S into S, so this is why we are taught that solubility is a constant at a given temperature. Because if I get solubility as root Kp, the real constant is Kp. But root Kp is also a constant. So we are taught that the solubility is constant, a given amount at a given temperature, and these many grams per 100 ml, and now these many moles per liter would be the maximum water will hold. So for a binary salt, solubility will be root Kp. Can somebody tell me why do I write it as Ba and not Ab? Almost every time you'll find a salt written as Ba. Ba2, yes please? Acid and base is what should come in your mind. And this is where you're so impressive at times, David. Spot on. This is the basic radical, this is the acidic radical. If I give you an example like NaCl, this must have come from NaOH and HCl. And you thought about this, you thought that the cation or the metallic radical will come from the base. All right, we are generally used to writing the cation first. I hope you're understanding me. So this is the basic radical, this is the acidic radical. The cation is called the basic radical because it comes from the base, and the anion is called the acidic radical because it comes from the acid. So I write Ba instead of Ab, and I think you're happy with this. बच्चे लोग हाँ ना बोलो. If it's a situation like Ba2 becoming B plus 2 and 2A minus, it's a ternary salt. It's a ternary salt. Now this time if the solubility is S moles per liter, this will give you S moles of B plus 2 and 2 S moles of A minus. Yet again I could write KSP as B plus 2 A minus n square of this, which will be S, and 2S plus square, which will be 4S cube. And in this case, if 4S cube is equal to KSP, I'll write solubility as the cube root of KSP by 4. Yes or no? So these are small little facts which are there in all textbooks. I'm sure you would have seen it in the past. And there will be very basic, simple questions where you have to calculate KSP from solubility or vice versa. Just keep one thing in mind, that henceforth solubility will be in moles per liter only, or molarity only. A salt like Ba3, which will be quaternary and will give you 4 ions, and if the solubility is S moles of this and CS moles of this, KSP could be very well 4th root of KSP by 27. I can remove this clutter a bit of. चलो तो दो फॉर्मूला खुद निकालो. What if it is a form like B2A2 or B2A3? You can do this in 2 to 3 minutes. Akshan, are you able to hear me loud and clear?
Yes, sir.
Have you been there from the beginning or you joined just now?
Sir, 20 minutes ago.
Are you understanding me?
Yes, sir.
चलो good to I'll talk to you once the class gets over. आकृति
Okay.
अदीप्तो सुनते पाচ্ছ?
Yes, sir.
Now basically I expect you to come up with the answer now. Fourth one, what is the relationship between solubility and KSP? Solubility is hello. हम यहाँ से 2 मिनट बोलो बच्चे लोग. Is it like KSP by 16 and fourth root of this? Huh? You're all getting it? And for this one, KSP by and so this is what everybody is coming up with. All right, so very quickly, if this is solubility, this is 2s and this is 2s, and I could write KSP as 2s and square of this and 2s square of this, which will be basically 16s to the power 4, which will give me solubility as KSP by 16 and fourth root of this. This looks all right. And with the solubility S, if this is 2s and this is 3s, naturally KSP would be, people online, are you able to understand me?
Yes, sir.
So this will be 2 to the power 2, 4, 3 to the power 3, 27. 27 into 4 is 108. And this square s cube is s to the power 5. And this will give me solubility is KSP upon 108 and substitute of this. We want to move on. बच्चे लोग खाना बोलो. तो ये सब बिल्कुल रूटीन चीज है. जेई मेंस में कभी कभी पूछता है, स्कूल एग्जाम में भी पूछ सकता है. Simple as you get. And in general, if you have a compound like P, P, Q, Q, which will break as P moles of P with a power say Q plus and Q moles of Q with a power say P minus. And if the solubility is S, you'll have PS moles of this and QS moles of this. And KSP would be PS to the power P and QS to the power Q, which would say give you S P plus Q and P to the power P, Q to the power Q as the general expression of KP. You'll be surprised to see that questions of this kind eventually make way to the advanced as well. मैं हार्ड कॉपी तो अब नहीं दे पा रहा हूँ तुम लोग को, पर जो सॉफ्ट कॉपी में भेजा था जी एडवांस में ऐसा क्वेश्चन आता है, ऐसा नहीं है. जी एडवांस में बहुत सिंपल सिंपल क्वेश्चन भी आते हैं. At the same time, from solubility product, there could be some very tricky questions as well. It's going to be a blend of solvable and tricky questions in the real exam. I'll take up more on solubility in problem solving. Right now, what I'll do is, if you're all happy with this, we'll see the applications of solubility product and a few more when we solve problems. I'll give you a couple of questions and then we'll move on to some more topics in anic equilibrium. So far, so good, I believe. You're all happy with this? You're all happy with this? Suppose I give you a question like case P of AgCl is given to be 1.6 into 10 to the power minus 9 at a given temperature. Find solubility of AgCl in pure water, a solution which is 0.1 molar NaCl or solution which is 0.01 molar is used. I'll give you a couple of minutes to attempt it. All right, I'll give you a couple of minutes to attempt it. Rather, I'll give you a little more than a couple of minutes. Take 5 minutes to attempt it. So I'm sure you would have done the first one. In pure water, in pure water, solubility Ksp as S square and solubility as root Ksp. Now this could be written as 16 into 10 to the power minus 10. Yes or no? This will be 4 into 10 to the power minus 5 moles per liter. I think you're all happy with this. बच्चे लोग हाँ ना बोलो.
Yes, sir.
ये तो सबका आ गया ना. 4 into 10 to the power minus 5 moles per liter. सबका आ गया. I told you NaCl is completely soluble. जैसे यहाँ पर इक्विलिब्रियम लिखते हैं ना, NaCl में नहीं लिखते हैं. पानी में मैं बोलता हूँ NaCl नहीं होता है, Na प्लस होता है और तो ये 0.1 से 0.1 दे दिया. दिस इज अ लॉट ऑफ Cl माइनस. ठीक है. I'll tell you initially the school way of doing it. The school way or the formal way of doing it. And also tell you the loop in which they put you in. So initially you will be told कि इसका भी solubility है, इसका भी solubility है, so ये 0.1 है तो 0.1 को यहाँ पर ऐड कर देंगे. And they'll claim that Kp which is 1.6 into 10 to the power minus 9 is solubility and S plus 0.1. And you would have seen it in all the textbooks. I think you're understanding me. Ag plus solubility, Cl minus solubility, Cl minus बहुत NaCl से आ रहा है, उसको ऐड कर देते हैं. And you know, you'll find a very, very familiar statement. Because S is small, S square is very, very small and ignored, neglected. हर किताब में ऐसे ही दिया रहेगा. S बहुत छोटा है तो S स्क्वायर बहुत बहुत छोटा है तो इसको इग्नोर कर दो. और अगर उसको इग्नोर कर दोगे, you'll get 1.6 into 10 to the power minus 9 is equal to 0.1 S or solubility as 1.6 into 10 to the power minus 8 moles per liter. Yes or no? Yes or no? अरे जब एस स्क्वायर को इग्नोर ही करना था, एस स्क्वायर को इग्नोर ही करना था, तो यहाँ पे एस लिया क्यों? I mean, a smarter way of doing this would be, you'll need to do this when it comes in the school exam. You'll exactly follow the protocols. You'll want to put up a statement like, because this is small, this square is very, very small and neglected. But don't you think a simple approach would have been 1.6 into 10 to the power minus 9 is equal to solubility, which is Ag plus, and Cl minus, which is 0.1? We'll believe the amount of Cl minus from NaCl is so big. I'll assume more of Cl minus is coming from NaCl. This will solve the problem right away. Yes or no? बच्चों लोग हाँ ना बोलो. It's like common and effect. It's like common and effect. जहाँ पर एक strong electrolyte और weak electrolyte जब लेते थे, we used to believe that the common ion is coming from the strong electrolyte only. So we'll believe that all of Cl minus is coming from NaCl only. All of Cl minus is coming from NaCl only. Yes or no? And if it's fetching a product of this equilibrium, naturally this equilibrium will go back. This equilibrium will go back. देखो solubility almost 1000 times कम हो जाता है. 10 to the power minus 5 से 10 to the power minus 8, the solubility reduces almost 1000 times. Yes or no? (0.01 molar silver nitrate). And when it's in 0.01 molar silver nitrate, you have to find the solubility of AgCl in 0.01 molar silver nitrate. Nitrates are completely soluble. I'll know silver 0.01 would be the silver I'll take here. So this time 1.6 into 10 to the power minus 9. मैंने ये solubility plus 0.01 का झमेला में नहीं पढ़ूंगा. Are you understanding me? I'll directly take Ag plus from 0.01. A textbook way of doing this would be 1.6 into 10 to the power minus 9 would be S plus 0.01 into S. And again, ignoring S square, it will be 0.01 S is equal to. So you understand, I don't go into this loop when I have to do it for an entrance exam. And I cut it short. Silver nitrates, all nitrates are completely soluble. Sodium chloride is extremely soluble. Has anyone taken a printout of the problem sheet which I was supposed to give you today? There is a question like this. KSP of Ag2CrO4 is 1.1 in 10 to the power minus 12 at 298 Kelvin. Came in 2013. अच्छा एक चीज और समझ लो, जैसे कॉमन एंड इफेक्ट होने से Ag प्लस आने से इक्विलिब्रियम पीछे आ जाता है, Cl माइनस आने से इक्विलिब्रियम पीछे हो जाता है. Something which will dissolve AgCl. I don't know if you're told or not. I don't know if you're told or not, but AgCl will dissolve in ammonia. Do you know this? AgCl is a very, very popular Curdy white PPT, which is soluble in ammonia. This would be a very, very popular statement in all of inorganic chemistry. AgCl with ammonia would form something like AgNH3 whole twice Cl, which will be a soluble complex. So this would remove Ag plus. This would remove Ag plus from the equilibrium. So at some point of time, if suppose you're asked to find solubility of AgCl in pure water, 0.1 molar NaCl, 0.01 molar AgNO3, and any amount of ammonia, and if the corresponding values are some SA, SB, SC, and SD, so far you know that SD and SC are going to be smaller values, yes or no? So more common and would mean less solubility. So you know SB is less than SC, which is less than SA, yes or no? Add SG to the list. I'll prove this when the time is right. I'll prove this when the time is right. Like a common and decreases, 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 like a common and decreases solubility. You saw that? Something which will be dissolving the precipitate or removing the product would facilitate it forward. We'll talk about it when the time is right. But I think you're understanding me. बच्चों लोग हाँ ना बोलो. Now we'll take up a few more questions. I mean, we need to talk about indicator story. We need to talk about. I think we have time to take a couple of more questions. एक दो question और करो. People online, can you hear me loud and clear? बच्चे लोग हाँ ना बोलो. People online, please respond. So this came in 2013. This came in 2013. JEE Advanced 2013. JEE Advanced 2013. They tell you KSP of Ag2CrO4 is 1.1 into 10 to the power minus 12 at 298 Kelvin. Find its solubility in 0.1 molar AgNO3. And I'm not going to give you the four options. I shall write one more question here. This came in 2008, very advanced only. KSP of MX is 4 into 10 to the power minus 8. KSP of MX2 is 3.2 into 10 to the power minus 14, and Kp of M3x is 2.7 into 10 to the power minus 15. Arrange in order of solubility. I'll give you 5 minutes to attempt. 5 minutes, huh? बट मैं पहले बहुत टाइम दे चुका हूँ, अब तू मेरे साथ में कर. You tell me what do you want to do with this problem. Has someone got the answer to this? And that is, I mean, you could speak with a little more confidence and with a little more conviction. 1.1 in 10 to the power minus 10 or minus 11. Now, Ag2CrO4 first of all produces 2 Ag plus and CrO4 2 minus. So every time you get Kp, which is 1.1 in 10 to the power minus 12, it's going to be Ag plus and square of this. Yes or no? And I told you, we'll keep it simple. We'll not go into the loop of taking solubility here. We'll take all Ag plus, which is coming from silver nitrate, which is 0.1 plus square, and solubility here. So solubility now would be 1.1 10 to the power minus 10. पहला बात. दूसरा बात, yet again I repeat, this came in JEE Advanced, so it's not a very challenging question, and a right thinking man would right away look at this question and would arrive at the right option, maybe without lifting the pen at all. All you need to figure out, very much in your mind is 2 Ag plus and 0.1 square would go into the denominator, and solubility will be 1.1 and 10 to the power minus 10 only. Yes or no? Does someone have an answer to this as well? So somebody is telling me Mx more than M3x more than Mx2 is the order of solubility. Are you all happy with this? चलो खाना बोलो. Well, when it comes to finding the solubility, I would take this as root of 4 into 10 to the power minus 8. This as root of 3.2 into 10 to the power minus 14 upon 4 and cube root of this, and this has 2.7 into 10 to the power minus 15 upon 27 and fourth root of this. Yes or no? The solubility of Mx would be 2 into 10 to the power minus 4 moles per liter. For M3x, now I could take this as cube root of 32 into 10 to the power minus 4 by 4, which will be minus 14, which will be minus 15 now. And 8 the cube root would be 2, 15 the 10 to the power minus 5. Yes or no? तो इतना टाइम नहीं लगता है, just to give you enough time for MX2. And for M3X, I could write 2.7 as 27 10 to the power minus 16, and 4 square root of this would give me, so it's mx more than m3x more than ms2. I'm happy some of you could do it of your own. And as I told you, we'll take up a few more challenging questions of solubility product in the next lab. Time now to move to the next topic. Give a heading, indicator theory. Next heading should be indicator theory.